This week on Just Solutions, world leaders at the COP26 Climate Summit have pledged to end and reverse deforestation by 2030, recognising the crucial role forests play in absorbing carbon dioxide and slowing the warming of the planet. Suzanne Simard, Professor of Forest Ecology at the University of British Columbia, has changed our understanding of forests and trees. In her latest book, Finding the Mother Tree, Discovering the Wisdom of the Forest, she explores the communal nature of trees and their shared network of interdependency. Dr. Simard calls for bold reforms that recognise the link between our forests and the climate change and biodiversity crises facing the entire world. From Free Speech TV, Just Solutions. Suzanne, it's so great to have you with us. Thank you very much for joining us. Well, as we heard there, global leaders at COP26 have made a pledge in Glasgow to end deforestation. And it seems that it is urgent because, according to World Resources Institute, last year the loss of primary old growth tropical forest rose by 12%. That was over 2019 figures. And we know deforestation is an issue worldwide. How do you feel about that pledge? Is this something that you think is positive or maybe does not go far enough?
No, I think that it's really positive. It's, that is exactly what we need to do is end the harvesting of our old forests and to restore the forests that have been damaged. I think that it's, it comes down to the details and how it's interpreted and whether or not it's reinforced. So, the intention is there, the goal is good because forests do, even though they only cover 1/3 of our whole Earth area, they actually absorb a disproportionate and store a disproportionate amount of carbon. 70 to 80% of terrestrial carbon is actually stored in forests and the soils underneath them. So yes, keeping these old forests is absolutely crucial, but it comes down to, how do you define deforestation? So I can imagine, like, for example, in my country, how, they could argue that, well, we replant these forests, these old growth forests that we log, and therefore it doesn't count as deforestation. And that really isn't the intention here. The intention here is to leave these old forests standing, at any cost, because we need them for their carbon storage. Really, making sure these definitions are solid and countries actually follow them. And then when, countries that are dependent on logging, especially developing countries, that we compensate them for leaving these forests standing so that they can get livelihood or they can get funding from other places.
Well, we'll talk a lot more about that in just a moment. But in the beginning of your book, in the early pages, you say that this is a book about how trees might save us. It's not a book about how we can save the trees, but how the trees can save us. And of course, it's a very personal story about your own journey through forestry and literally through forests as well. But you touched on it there, that forests and trees have a crucial role to play in the climate crisis, in absorbing carbon. We use these terms a lot: carbon sequestration, carbon capture, but I'm not sure people necessarily understand the really crucial role in that. And then we're seeing a huge loss of particularly the old growth forests, what that means. So for maybe the layperson, what does carbon sequestration, when it comes to forests, carbon capture, what's going on?
Yeah, it's really it really comes down to photosynthesis. So and that's not that hard to understand. I mean, it does have a lot of complicated pathways, but essentially what that means is that trees and plants, by virtue of their green leaves and the chlorophyll in their leaves, are able to actually take carbon dioxide out of the atmosphere, combine it with water that they bring up from the soil through their roots, and turn it into sugars. And then in the process, these trees give off oxygen. And that very oxygen is what allows us to breathe. We need these trees and plants to continue to do photosynthesis so that we can have a habitable environment. And in fact, it was the oxygenation of our planet through photosynthesis and the development of photosynthetic plants that allowed human beings to evolve. So we are completely interdependent with these forests and with the plants. And then the trees, when they photosynthesize, they take those sugars and they do things with it. Basically, it's the energy that runs the forest. So some of that energy is used to carry out the metabolic functions of the trees, including production of all kinds of tissues like other leaves and wood and roots. We produce all that biomass and the metabolic processes associated with that. And then a large portion of the carbon is actually excreted or exuded into the soil itself, and that feeds a whole soil food web, and that food web decays or it goes after organic matter to get nutrients for the tree and water. And then that food web, of course, turns whatever decaying material is into humus, and that is that's very high in carbon content. And we have found, in general, that forests after going through all these processes they actually store about half of their carbon below ground in this process. So so sequestration is simply photosynthesis. Storage is simply putting that carbon into stable pools, whether it's in the above ground parts of the tree or the below ground, the roots, and then the soil pool. So that's called storage.
So related to that, in the role that trees and forests, particularly those old growth forests, play in help mitigating some of the impacts of the climate crisis, does deforestation itself, in addition to removing the capacity then for photosynthesis and the carbon capture, does the actual act of deforestation itself release carbon into the atmosphere, exacerbating?
Yes, it does. Yes, it does. So, so the first thing happens when you deforest or when you clear cut a forest, you take the living material, basically the trees, and turn them into products. So, they're cut down, they're turned into things like toilet paper or cardboard. Some of it is turned into long-term products that store for a long time, like houses. But in general, analysts have found that about 65% of the average forest logged in North America is turned into products that are very short term and basically emitted to the atmosphere immediately or within a year or two. So the vast majority is turned into things like paper and toilet paper that decomposes very quickly and is in the atmosphere. So that's a major input. And then the next input is without trees over top, the soil itself can start to decompose. And the reason that decomposition can be important is in the process of logging, like this machine here, they're actually moving forest floor around or putting it in piles and then burning it. And we've found in our research that in British Columbia that we're losing about 60% of the forest floor through this kind of mechanized logging. And then that exposes the underlying soil and churns it up and exposes it to the air. And so we get further decomposition. And so not only have we lost the trees and converted them the vast majority of it into CO2, but we also have released CO2 from the removal, disturbance of the forest floor, the organic matter in the soil, and we lose about 60% of that. So clear-cut logging really is devastating to the carbon pool in a forest.
And you've written about the impact on the other trees of having such industrial activity right in the heart of these old growth forests. What's happening with the birch, with the aspen, who are mowed down essentially to get to those larger trees?
Yes. So in a clear cut, they're really after the most lucrative trees, which are generally the biggest conifers, at least in North America. And or in the Amazon, it would still be the biggest trees because they of certain species because they're sold on the market. But in the process of clear cutting, all the other plants are also damaged. So even the trees like birches and aspen up north here in Canada, those are also removed or cut down or put in piles and burned. And then the other thing that happens is when the forest starts to recover, it goes through a process called succession. And so that means that plants start to come back. That can be all the understory plants, salmonberry, thimbleberry, birches, aspens, alders. And at least in Canada, and this is a practice that's actually been adopted from the U.S. is that the perception is that when we try to grow back the conifers that we made so much money from, that they compete with the native plants, or the native plants compete with them, and so there's this practice of removing the native plants on top of that, and that includes birch, aspen, and so on. And so we really reduce the biodiversity of the forest in this practice of spraying the plants or cutting them out, and then making more room for these conifers, these marketable trees. But that reduces biodiversity. And the other important thing that we found is that these plants, these herbaceous and broadleaf plants, hold a lot of water. But the conifers are a much more resinous, drier, kind of more acidic group of species, and they're much more flammable than these broadleaf plants. And so when we remove the broadleaves and leave these flammable conifers, we're actually increasing the fire risk on our landscape. And that's really important today because, temperatures are increasing. We just went through this massive heat dome in the West that caused or ignited a lot of fires. And we also have high fuel loads from a century of fire suppression. And so by converting old forests, which are quite fire resistant, to these highly flammable plantations combined with increased fuel loads and high temperatures, we've created a perfect storm for fire. And so we really do need to remediate these forests, so that they are less flammable. We can do this, and we can go back to more natural or more extensive prescribed burning to get the fuel loads back down, or whatever practice we do to get fuel loads back down in our forests.
Well, you've written about the Aboriginal concept of stewardship over forests, and how the policymakers essentially are not embracing that. In fact, you say too many decision makers dismiss Aboriginal ways of viewing nature, because it does seem, certainly here in North America and really most parts of the world, nature is something to be commodified. It's a resource to be extracted. And you referred to that when we talked about the logging, as opposed to a resource to just be stewarded. I mean, talk a little bit about that, and how forest management policies, not just logging and the actual extractive industries, but forest management itself, views trees and forestry through that prism, that it's a resource and resources need to be extracted.
Yes, you're that's absolutely right. So if we look back, and I'm going to use North America again as an example, for 10 or 14,000 years or more, North America has been the home of many Aboriginal nations, many North American Indian nations, and First Nations in Canada. And their worldview is that we're all one together with our forests and our lakes and waters and the ocean, that we are, we care for each other. We care for the world, the environment, and the environment cares back. It's a reciprocal arrangement, or a reciprocal caring for our environment. And so it really, the practices, the Aboriginal practices, were all geared towards, making a wealthy, or I shouldn't mean in terms of healthy living environment, so that's full of food and shelter, and that it really you live in concert with the salmon and the trees and the bears, and create a beautiful, healthy, vibrant life. And that is how life carried on for thousands of years in North America. Although, of course, there were many conflicts and all this too, but that was the basic way of living in the world, of living with and among and interdependent with the resources, the natural gifts of the world. When Europe colonized North America, that was not the worldview. I mean, the worldview was, we're going to invade, we're going to exploit, and we're going to populate this continent. And so that exploitation view has carried on today, and it really has become like the bedrock of capitalism, and it's also changed. It's changed the people, it's changed the landscape, and now we see today, that's continuing on. That forests are just meant there to be mined or exploited and turned into products, and then regrown back to again cut them again in 50 or 100 years to make more products, and on it goes. So we're not treating it as a life support system, but really as an avenue to feed the economy. And the problem with this is that when this was happening, it was not centered on ecology. It was centered on economics. And these two things can go hand in hand, but you have to understand the way of the land in order to manage it properly. And what happened was that basically practices in Europe were just sort of applied carte blanche almost to North America, and that didn't fit the landscape. And so, there's many more reasons, but that is really causing the demise or the degradation of our forests in North America.
We'd love to hear from our viewers. Let us know where you're watching. What's your relationship to trees, to forests? Are you aware of the potential and the capacity to help mitigate some of the impacts of the climate crisis through better forest management and the investment into stopping deforestation? Suzanne, you're going to be speaking at the upcoming Bioneers Conference, and I know people are very excited to hear more about how you have really transformed how people and science and hopefully policymakers will view forests. Because before, getting back really to what you said before in terms of the attitude in forest management has been resource management essentially, as opposed to really seeing the broader ecosystem. There was a sense that trees competed amongst themselves. It's a very capitalistic model, I suppose, to look at trees and go, well, they're fighting for resources themselves, essentially light. Where what your research has really shown that instead of that, trees are working together to help each other and to support each other around that hub of the mother tree. So take us through that, how trees are in fact working in community, in cooperation with each other.
Yeah, so you're absolutely right. So back, in the 70s and the 80s, when industrial forestry was really taking off, the view was, which borrowed from Darwinian understanding of fitness, survival of the fittest, and natural selection, that it was competition between species and competitive exclusion that led to speciation, the development of new species or the adaptation of existing species so that they are better adapted to their environment. And this idea that they compete is true. I mean, competition is a real interaction in forests, among plants, among trees. They do compete for light. A really simple example is one tree can be taller than another and shade the one underneath, and so that is considered competition. So this idea really took hold when forest management was being developed and applied, not just in evolution, but to ecology, and forestry is just applied ecology. And so the idea that everything was governed by competition, even the structure and development of forests, really took hold. And this came hand in hand with the development of capitalism, in Europe and then in the United States and Canada, where, it became like the way to do business was to compete and to dominate and become the richest and the best. And so these things kind of developed together, ecology and capitalism, or the economy. And the problem with this approach is that it's just a kind of blind. It's blind to the fact that trees, as people, have interactions and relationships that are much more complex than that. Yes, they do compete, but they also collaborate at the very same time. They have a whole suite of very intricate and sophisticated relationships. So, for example, while a birch tree might shade out a Douglas fir that's underneath it, so competing for light, it also connects with Douglas fir below ground in a network of fungi, these mycorrhizal fungi that I study, which are literally a symbiosis between these creatures that live in the soil, the fungi, which, by the way, you see them when you're walking in the forest, the mushrooms that you see popping out of the ground, they're the fruiting bodies of this vast mycelium that is below ground that links these trees together. And it turns out that even as birch is shading Douglas fir and fixing carbon through photosynthesis, some of that carbon actually moves through this mycelium directly into the Douglas fir trees. So they're sharing photosynthate at the very same time that they're shading them. And so you would think to yourself, why would a birch tree do that? Well, if you think of the entire community as working together each species with its own job, its own niche. That diversity is actually what makes the community healthy and productive. So birch and fir, for example, will be accessing nutrients from the soil in different ways because they have different root systems. They harbor a number of different mycorrhizal fungi. They host a kind of a slightly different soil food web. And so they can access a more complete pool of the total resources on the site. And as you add species, in general, that's what nature has done, is it's filled in these niches so that we get complete resource uptake. And so by our parochial view that birch is a competitor and not actually doing anything else in this community, we've actually, short-circuited that ability of this whole community to take up the resources and be very productive.
And so what is the mother tree then? And what is the role of the mother tree in that ecosystem?
Yeah, so the mother tree, what we did is we went out to map what these networks look like in real forests. And so we went into a Douglas fir forest that was multi-aged with big trees. You can see some of these great big trees in this video. Those are the biggest, tallest ones are the mother trees. And we found in making the map of what this network looked like that everything was connected to everything else below ground in multiple links. And that the biggest, oldest trees were the most highly connected. That's because they have these huge canopies, photosynthesizing, allocating carbon below ground, and having lots of roots that connect to all the other trees and seedlings all around them. And then these seedlings benefit from that huge network to access resources. And at the very same time, these mother trees actually send these little seedlings carbon and nutrients and water to support them while they're, youngsters, as they're teenagers, as they're growing up into young adulthood. And then that dynamic, as the trees age and they change status in the crown, they actually that source sink or whatever, that movement actually changes over time, but it's ongoing. It's there all the time. All these trees are linked together. And the biggest, oldest are the nuclei, or the hubs of the forest, the matriarchs of the forest.
But when you think then of the deforestation practices, especially that logging and that industrial activity going on, that does not acknowledge in any way that very rich and complex social ecosystem, that must be devastating then. Given that a tree is not in and of itself its own thing, it's so related to many other living creatures in the forest.
Yeah, I think, the most poignant part of this is that, we target those mother trees. Those are the biggest, most lucrative trees in the forest. And so those are the ones we go after to make money from, but they are the linchpins of the forest. And so once you take those out, it unravels the ecosystem because they really are the holders, the container of so much of the energy in the forest. So, yeah, it is devastating. So there are things we can do, though. We can leave these old trees behind. We can take, if we need wood, which, human beings always have used wood, and we will continue to use wood, but we can do it in a much more sustainable manner. So that means leaving these big old matriarchs in the forest, if we're going to log them, and then just taking out the smaller ones. And by the way, I just make sure we don't feel a contradiction here. We still need to save our old growth forests, and that the logging, when we do it, needs to shift away from these incredibly rich, productive, ancient forests where we have so much carbon and biodiversity, shifted over to second growth forests, where we've already lost so much, right? We lose, a lot of the carbon and richness of species when we log in the first place. So when we log, we should do it in these second growth forests and then leave these big old trees behind, and they can then start to form these old growth structures eventually as well, and start to enhance that old growth nature, or the older trees across the landscape, which, are so essential in carbon sequestration and storage.
So from what you're saying there, it sounds like there is a way to have some type of sustainable forest industry. It just needs to be done in a very conscious way.
That's right. I think we can have a sustainable industry. It starts with revaluing forests for their life support systems that they are, instead of just 2x4s. It means, saving the remnant forests we do have for their life support systems. It means when we do harvest, to go into, these second growth or less productive forests where there's less less carbon storage, and then doing very careful logging where we're craftsmen, not miners. We're craftsmen that go in and take out just individual trees and leave a large part of that legacy behind. Because when we do that, the forests naturally regenerate more easily. But as climate changes, we're going to have to be more and more conscious of this to leave the environment so that it can reproduce, instead of making these big open areas that are very hard for seedlings to get going back in. So being very, very careful about this, about the logging, and also logging far less. We need to consume less wood overall, just like we need to consume less of a lot of things that produce carbon dioxide. As a population in the world, we need to be not just conserving, but reducing and being less consumptive overall. We can do that.
Well, just in the last few minutes that we have, I don't want to go too far down a rabbit hole of political analogies, but it does seem when we see what's happening with trees living in community to benefit each other, there's a lot we can learn from trees, particularly if you look at where we are right now in society, and we are in the middle of a pandemic and we are relying on other people to get us through this. And we can only survive the various crises that we're facing with cooperation. I mean, have you thought about that, or what we can as a society actually learn from trees?
Yes, absolutely. I mean, I think that this is why people are understanding this work that I've published in the Mother Tree, because it's natural for us. We're social creatures, so are trees. We're interdependent. We're a collective where we collaborate, we work together, we have special jobs, we help each other through difficult times, and I think that with the advent of capitalism, it's been a great big, I call it a big experiment of let's not have those, let's not depend on those social qualities. Let's depend on ourselves. I can compete for my resources, and I'm going to make as much money for myself as possible. It's the rise of the individual, and I'm going to get rich. And that is what's happened, is that we've created this unequal society where some individuals are extremely wealthy, and then there's most of the rest are either in middle class or under the poverty line. And this lopsided distribution of wealth is not how we're naturally wired to behave. We're wired to behave as social creatures where there's cooperation and competition, but it's a whole sophisticated way of interacting. Same thing in forests. And so, yes, I think that we can learn a lot from this, that we can go back to our so-called roots, pun intended, that we have this ability to be social creatures, that we can change our politic to have a stronger social safety net, to care for each other instead of letting some fall through the gaps because, hey, you're not the most competitive and dominant person well, we all have a niche, we all have a role, and they're all important. And so, yeah, I think we really need to take a hard look at this, because really it is that social that is caring part of our society that's going to get us through climate change. That's what's going to get us to cooperate together, figure out these solutions, act together, and solve these problems, instead of letting a few very rich people dominate and basically govern what we're going to do. No, that's not going to work. It's got to be all of us working together, and out of that collective behavior, then we have emergent, brilliant behaviors and ideas.
Well, in addition to your book, Finding the Mother Tree, I know you have the Mother Tree Project, mothertreeproject.org, and there is a lot of information and inspiration, I would say, as well, for people to get involved in this. And as we mentioned before, Suzanne will be participating in the upcoming Bioneers Conference, and we are very excited at Free Speech TV to once again be partnering with Bioneers. So do stay tuned for lots more information and great content on that. But in the meantime, Suzanne, are you hopeful as we sign off today?
Yes, I am hopeful. And the reason I'm hopeful, not only because I have daughters and I care about them and they're, the children that they ultimately have and the next generations, these kids are ingenious. So, I mean, humans are incredibly ingenious when we work together. And I see that in my kids, my classes, and I want them to thrive. The other thing is that I understand how systems work, right? Ecosystems, social systems, they work together. It's about the relationships that they build that makes them work and be beautiful and create amazing things. And they're resilient. These systems, social systems, ecosystems, have evolved for that resilience and for creating biodiversity and clean air and clean water. All of that emerges out of these complex behaviors. And so the systems are wired to heal. They're wired to be productive. It takes a lot to wreck them. And so if we get all the pieces back in place, like the big old trees and healthy soil and good water, that these systems will recover. But they do need our help. They need us to be doing our part, which is helping them and helping each other to have, healthy and productive lives instead of exploitive. So being regenerative instead of exploitive.
Well, Suzanne Simard, it has been so great to have you as a guest on Just Solutions. Thank you so much for being with us.
Thank you very much. It's my pleasure.
Don't forget, Just Solutions is available as a podcast, so you can listen to this episode or any episode anytime. Just subscribe wherever you get your podcasts. From Free Speech TV, Just Solutions, I'm Maeve Conran. Thanks so much for tuning in.